Problem number 3. Brittany ran 3.5 miles in a half an hour. At this rate, how long will it take Brittany to run 1 mile? All right, let me move this over so we have some more room. And then I'll go over the scribble tool. The big clue for me in this problem is that it says rate. And then also this part where it says 1 mile. That clues me in to the fact that they're asking me to find a unit rate. So when I think of unit rate, I think of k equals y over x. I think of constant proportionality. I think of k. So that's what they're asking me to find. They're also telling me that the value that needs to be 1 is the miles. So remember, when you think about the formula k equals y over x, that unit rate formula, when the x value is 1, then the y value is the unit rate. So they are basically telling me that I need to put miles in the denominator, because when I divide, it will make it so that the denominator becomes 1. And then they're telling me then, well, if miles is in the denominator, then that means that hours must be in the numerator. Now this is important because normally if I would look at this, normally we would do miles per hour and would figure out how many miles she can travel in 1 hour. But this problem is not asking that. It's asking us how long it will take her to run 1 mile. So in this case, we're actually going to put the hours in the numerator. So the 1/2 hour goes in the numerator, and the miles, 3.5, goes in the denominator. And now we have complex fraction. Step 1 in our complex fraction work is to make sure the numerator and the denominator are fractions. The numerator is already a fraction. The denominator is a mixed number. I need to change that to an improper fraction. So to do that, I multiply the 3 by the 2, and I get 6. And then I add the numerator to get 7. The 7 goes in the numerator, and then the denominator remains a 2. So the denominator stays the same. So now I've changed my mixed number to an improper fraction. It's improper because the numerator is larger than the denominator. This is called a proper fraction because the numerator is smaller than the denominator. Right, the next step is to change out this fraction bar for a division symbol. Then I record the numerator fraction first, the 1/2 goes first, the denominator fraction goes second. And then the final step is to apply the keep, change, reciprocal method. So I keep the 1/2, that's locked in. I change the division to multiplication, and I write the reciprocal of 7/2. And then I multiply the numerators, and I get 2, a product of 2. I multiply the denominators and get a product of 14. And then I realize that 2 and 14 are both even numbers, so I can reduce this fraction by dividing each by 2. 2 divided by 2 is 1, and 14 divided by 2 is 7. And we were being asked, at this rate, how long will it take Brittany to run 1 mile? So it will take Brittany 1/7 of an hour to run 1 mile. The only thing I wanted to see is if this was a good speed. So I'm just curious, so I'm going to go a little bit further with this problem. And let's think about how many minutes are in an hour. So 60 minutes are in an hour. So if we take 1/7 of 60, we would get 60 divided by 7. Multiplying by 1/7 is the same as dividing by 7. So I'm going to go over to Desmos. I'm going to take the 60 minutes and divide it by 7. And if it takes her a seventh of an hour, that would be about 8.6 minutes. So that's not bad. It's not super fast, but that's a good pace to be running at. And the pace that she was keeping, she kept for, look, 3.5 miles. So that's good. So that it was about 8.6, I think, minutes is what it said. And we didn't have to do that. I was curious what 1/7 of an hour would be equal to.